Hi, sorry I couldn't be in today. I decided to record a video to try and make this a little bit smoother while I'm gone. And today we're going to cover section 7.2, which is solving trigonometric equations algebraically. So the goal for today is to solve first and second degree trig functions using the algebraic method. So we're going to go through 3 examples today, and that should hopefully get you started with the questions in the textbook that I already assigned yesterday. And if you have questions with the textbook work, we can go over those tomorrow as soon as I get back. Okay? So the first question we've got here says, without using graphing technology, determine the exact roots of the following first degree function. And the function is square root of 2 sine x minus 3 is equal to negative 2. For negative 360 degrees is less than or equal to x, which is less than or equal to 0 degrees. The first thing I want you to notice when we're looking at this equation is the domain in which we're solving for. We've got a negative domain, and the other thing that we're looking at is that it is in degrees. So we're going to be looking to solve our equation, solve for x, and we want to figure it out in degrees rather than radians. We're also going to be going clockwise around the circle. So we're going to keep that in mind as we solve this question and go from there. Now, given this equation, yesterday what you looked at was how to solve this equation by popping it into our calculator and finding the intercepts. Today we're going to try doing this algebraically. We're going to try it with no calculator, and a lot of these questions that we do today are going to be using our special triangles that you've learned from the unit circle in the previous unit. So the first thing that I'm going to suggest when we're solving a question like this is we're going to try and rearrange the equation so that we're solving for sine x, and we're going to solve for x. So the first thing we're going to do is we're going to add 3 to both sides. So now I have square root of 2 sine x is equal to positive 1. And we're going to divide by the square root of 2. So now we're left with sine x is equal to 1 over the square root of 2. Now this is in a form that we're not really familiar with. We're familiar with no radical numbers on the bottom. So we're going to rationalize the denominator and see if we can get it into a form that we're more familiar with. To do so, I'm going to multiply by the square root of 2 over the square root of 2. So you can see here that I've really multiplied by 1, and I'm allowed to do this. This gives me the square root of 2 over 2. Now that we've done this, square root of 2 over 2, I'm hoping that you can see that this is familiar from the unit circle. So I'm going to give you a second, pull out your unit circles, and see if this corresponds to any location on your unit circle. And we've got sine x is equal to square root of 2 over 2. We know that sine x corresponds to the y values of our unit circle. So we're looking at points on the unit circle where y is equal to the square root of 2 over 2.